In this section, we're going to do a review of right triangle trigonometry, and we're going to do a brief review of the trig functions sine, cosine, and tangent. And you may remember from high school a little saying that was called so katoa, and that's what we're going to write across the top here. So, S-O-H. This is for your sine function. To calculate the sine, you're going to do the opposite over the hypotenuse. Ka, C-A-H. This is for the cosine. To be able to figure out the cosine, it's going to be the adjacent side over the hypotenuse. And then toa, T-O-A. This is for tangent. In order to do tangent, our ratio is going to be the opposite side over the adjacent side. And in our first question, we're going to use this triangle over here to write a ratio to represent each of the following. The first example, they want the tangent of angle A. So I'm looking at angle A, which is right here on my triangle. And to find the tangent, the ratio is going to be the opposite side over the adjacent side. So the first thing I'm going to do is look across to the opposite side, which is a value of 5. Opposite over the adjacent side. Well, the adjacent side is this side right here, which is equal to 12. So the tangent of A is going to be the ratio of 5 to 12. For tangent of B, well, we're going to look at angle B here, and again, it's going to be the opposite side over the adjacent side. In this example, the opposite side to angle B is 12 over the adjacent side, which is this 5 right here. 12 over 5 is going to be the ratio for tangent of B. Okay? In the next example, we're going to use this triangle, and we're going to write a ratio to represent the following. Sine of A, cosine of A, sine of B, and cosine of B. For sine of A, well, here's angle A, and looking at my little saying up here, sine is the opposite over the hypotenuse. So I'm going to look across from angle A for the opposite side, which is 21, and the hypotenuse is always across from the 90-degree angle right here, which is 29. So sine of A is going to be the ratio of 21 over 29. For cosine of B, here's angle B. Cosine is the adjacent side over the hypotenuse. So I'm looking at the adjacent side, which is here at 21. And the hypotenuse, again, is going to be 29. So the cosine, this is for the cosine of A. Cosine of A is back up here. A is back up here. The adjacent side is 20. The hypotenuse is 29. So it's going to be the ratio of 20 over 29. Okay? For sine of B, now I'm going to look at angle B. The opposite side to angle B is located at 20. The hypotenuse is 29. Opposite over hypotenuse, 20 over 29. For angle B, the cosine of angle B, well, it's going to be the adjacent side, 21, over the hypotenuse, which is 29. Notice here, sine of angle A, is the same as cosine of angle B. They were each 21 over 29. And it's the same with sine of B. Sine of angle B is equal to the cosine of angle A. They were both equal to 20 over 29. In the next example, we're going to look at our picture and we're going to set up a trig ratio so that we can figure out the measure of a missing angle. Our angle right here is called theta, and based on where theta is located, I've got to look at the sides that were given. Okay, for this angle, the sides that were given were the adjacent side and the hypotenuse. Adjacent and hypotenuse, I'm going to have to use cosine. So the cosine of theta is going to be equal to the adjacent, which is 12 over the hypotenuse of 15. We need to figure out what the measure of that angle is. So in order to get the value of theta, we're going to do the inverse cosine of that ratio, 12/15. This will give us our value of theta. So I'm going to use my calculator. Okay, and I'm going to find the inverse cosine. So I'm going to hit second cosine, and then I'm going to type in my ratio 12 divided by 15. And there's my angle. So I'm going to write all of that out. Okay, 36 and 869899765. Okay, and then if we were to round this to the nearest degree, we would say that this is approximately a 37-degree angle. Okay, for angle B, theta is located up here, or for question B, I should say, theta is up here. and the sides given this time were the opposite side and the adjacent side. Opposite and adjacent is tangent. So tangent of theta is equal to the opposite of 16 over the adjacent of 6. So to get theta this time, we're going to do the inverse tangent of 16 over 6. And again, this will give us our value of theta. So let's go ahead and punch this in. Second tangent, 16 divided by 6. And there is our angle measure, 69 and 4439, 5478. And again, if we were to round this to the nearest degree, it's going to be about 69 degrees. Okay, with our last example, here's where theta is located. The sides given are the opposite and the hypotenuse. Opposite and hypotenuse is sine. Sine of theta is equal to the opposite of 11 over the hypotenuse of 21. So to get the angle theta, again, we're going to do the inverse sine of our ratio 11 over 21. And let's punch that in. Second sine, 11 over 21. And this time we get 31 and 588135551. So our angle this time, theta, is going to be approximately 32 degrees if we go to the nearest degree. With the next set of examples, we have to figure out the measure of the missing side. We're giving an angle and we're given another value, another side. And based on the side that we're looking for and the side that we're given, we have to figure out which trig ratio we're going to use for the given angle. So here's our angle, 28 degrees. And the sides given are the ones opposite. That's actually the one that we're looking for. And the hypotenuse, opposite and hypotenuse, well, that's going to have to be the sine function. So the sine of our 28 degree angle is going to equal the opposite side, which is x over the the hypotenuse of 21. Okay, we've got to figure out what the value of x is. So we're going to multiply each side by 21. So to get x, okay, these are going to simplify. X is going to be equal to 21 times the sine of 28. And so we can go ahead and punch that into our calculator. All right, clear that out. 21 times the sine of 28. And I'm going to go ahead and write all of that out. We get 9 and 858, 902,819. And so we can say that x is going to be approximately, this says up here to go to the nearest hundredth, 9 and 86 hundredths, and the units given are centimeters. In example B, we have our 41 degree angle here. Okay, the side we're looking for is the opposite side. We're also given the adjacent. Opposite and adjacent is tangent. So we're going to have the tangent of 41 is equal to the opposite x over the adjacent 11. And to get the value of x, we're going to multiply both sides by 11. So x is going to be equal to 11 times the tangent of 41. Okay, we'll go ahead and punch that into our calculator. 11 times the tangent of 41. And we're going to write out all of that. 9 and 56215 for 116. Okay, and so we can say again to the nearest hundredth that x is approximately 9 and 56 hundredths, and the units again are centimeters. In example C, we're given a 53 degree angle. We're looking for the adjacent side, and they gave us the hypotenuse, so we're going to be using cosine. Cosine is adjacent over hypotenuse. The cosine of 53 is going to be equal to the adjacent side of x over the hypotenuse of 30. So we're going to multiply both sides by 30 in order to get the value of x. Okay, so x is equal to 30 times the cosine of 53. And again, we'll bring back our calculator. 30 times the cosine of 53. X equals 18 and 0.5445069. To the nearest hundredth, that's going to be 18 and 54, excuse me, that was thousandths I just went to. To the nearest hundredth, 18 and 5 hundredths, and the units are centimeters. Question 8 says that at 45 degrees the tangent value is equal to 1. What does that tell you about the opposite and adjacent sides? Well, remember, all right, for tangent, if tangent of 45 degrees is equal to 1, and if tangent equals opposite over the adjacent sides, well, the only way that this can equal 1 is if these two values are exactly the same. So it could be 1 over 1, or it could be 5 over 5, or it could be 1,000,000 over 1,000,000. The important thing to remember here is that in order to have the tangent value equal to 1, the opposite and the adjacent sides must be equal. And so that's what we can write down. The opposite and adjacent sides are equal. In our last section, again, we're going to be looking for the missing side x, and we're going to round our answers to the nearest hundredth. So this is very similar to what we were doing before. We have our 62-degree angle. The side we're looking for is the adjacent side, and they gave us the opposite side. Opposite and adjacent is tangent. So the tangent of 62 degrees is going to be equal to the opposite, which is 24 over x. Okay, so this is going to be slightly different than what we did before. If we multiply each side by x, okay, well, these x's are going to simplify. So 24 is going to equal x times the tangent of 62. But again, we're trying to get the value of x. So now we're actually going to divide each side by the tangent of 62. And now these will simplify. So x is going to equal 24 over the tangent of 62. Okay, and so this is what we're actually going to punch into our calculator to get that value for x. X is going to equal, let's go ahead and get our calculator here, 24 divided by the tangent of 62. We go ahead and punch that in, and we get that decimal there. 12 and 76102636. To the nearest hundredth, that's going to be 12 and 76 hundredths, and the units are centimeters. In example B, we have a 34-degree angle. We're looking for the hypotenuse. They gave us the adjacent side. Adjacent and hypotenuse is cosine. So the cosine of 34 is going to be equal to the adjacent of 18 over x. Okay, we would multiply both sides by x. Then we'd have to divide each side by the cosine of 34. So to get the value of x, we're going to actually end up doing 18 divided by the cosine of 34. And so now we can go ahead and punch that into our calculator. All right, 18 divided by the cosine of 34. And there's our decimal. So let's go ahead and write that in for x. 21 and 71192307. To the nearest hundredth is about 21 and 71 hundredths centimeters. Finally, with example C, we have a 48-degree angle. We're looking for the adjacent side. We have the opposite side. Opposite and adjacent is tangent. So tangent of 48 degrees is going to equal the opposite side of 12 over the adjacent side of x. That means in order to get the value of x in this case, we're going to have to do 12 divided by the tangent of 48. So let's go ahead and punch that into our calculator. Okay, 12 divided by the tangent of 48. And we get the decimal 10 and 80484853. And rounding to the nearest hundredth, that's about 10 and 80 hundredths, or just 10 and 8 tenths centimeters.